Okay, hey, hello. Um, this is a lecture on fingerprints. It's being recorded for JS 110, Introduction to Forensic Science. I'm Jason Linville, and this lecture is being recorded in the fall of 2017 in October. So if you're accessing this archive lecture in future semesters, all the material still applies, but if I mention anything about Halloween or cold weather or rain, I don't know what happens in October. You can ignore all that, or quizzes and exams, or upcoming assignments. I mean, for the fingerprints lecture, normally that's coordinated with a fingerprint assignment, which I've already gotten a couple questions about. Uh, by the way, if I'm asking for a Radier or ulnar loop, that's, I think, an error since I don't tell you which hand the prints are from. So you can just identify any print as a loop, a plain loop, and that'll be good enough. Arch loop or whorl, which we're going to learn about tonight in this lecture. All right, so let's begin. Well, let's begin with a sort of a fake case here. Let me get my drawing tool ready to go. All right, in fingerprints, I'll spare asking the people in the chat room as far as how this works. But if you find a fingerprint at the crime scene, then this, and you can answer at home or in the chat box right now, this fingerprint evidence, would this be our known sample or our unknown sample? Unknown is correct. 1 second. Ronan, I'm recording a lecture. I can't talk now. Please go see Mom. Thank you. All right. There, I gave you time to think about it. Okay, so we want to compare it to a known sample, right? And what is going to be the known sample that we're going to compare it to? All right, well, let's think. For, to go back, take it down to Mom, please, and she will fix it. My iPad's not working. So I think everybody has been in that situation before, right? So we're going to compare it to a known sample. With blood and semen and saliva, that was all identification of body fluids, so that really doesn't apply here. But when it comes to talking about firearms or DNA or footwear that we just had, we always compare that unknown sample to something known from our suspect, a footprint, known shoe from our suspect, fiber in a van, we compare it to the fiber from the suspect's van. DNA found in a bloodstain, we compare it to DNA from the suspect. And just like all of those items, for a fingerprint, our known item is going to be a fingerprint from our suspect. So then we get into talking about traits of fingerprints. What are the traits of fingerprints? And remember, we're not trying to identify it as a fingerprint, but we're trying to differentiate fingerprints from each other. And as with shoe prints, where we said, well, it's pattern and size, a fingerprint is also pattern. I mean, normally we don't have to look at the size. Why? Because every pattern's unique. So we don't have to go to that, oh, well, maybe they're two of the same shoe, but they're different sizes. Here, since everybody's pattern is unique, then we can just look at that. And the good thing about fingerprints is because you're not manufacturing fingerprints in a factory where you can have like the Nike swoosh symbol in a fingerprint, although that would be pretty cool. All fingerprints are similar in the way that their patterns are composed of ridges and valleys that we're going to talk about in this lecture. And therefore, forensic scientists can create a systematic way of measuring, evaluating, and keeping track of these patterns in software so they can be easily compared. So that's what we're going to look at this evening is fingerprints, how they are compared. This is a link to a fingerprint video where you can follow and watch it on your own time. I think if my memory serves correct, it's not the highest quality video, but the reason we watch this in classes sort of leads off a discussion talking a little bit about how there are different methods for developing fingerprints, and that's one thing that's really unique to fingerprints. With all the other evidence, you sort of find it laying on the ground at the crime scene. Hey, there's a bullet. Hey, there's a drop of blood. With fingerprints, sometimes they're latent, much more so for the shoe. And I'm getting a message. Boy, everything. See, I told you, the fingerprint lecture is jinxed. All right. So it looks like, everything looks, I got a message from Sarah that she cannot see the video. If Zai or Kaylin can find the chat box, let me know if you can still see the, I'm sorry. Sarah's probably talking about the video that the link is leading to, right? Okay, the link. Okay, so Sarah's saying that that video link is not working right now. I'll have to double check the link. We used this last semester, but things can change in several months on the internet. So who knows? Did somebody buy out Discovery? Maybe the Discovery Channel doesn't even exist now. But the video shows how there's different methods of developing fingerprints, and depending on the type of fingerprint and the type of material the fingerprint is on, you use different methods of developing it. And as I was saying, that's one thing that's unique for fingerprints, in that since fingerprints are often invisible, there's a lot of cool ways to develop them. I don't know. It's making something invisible become visible tends to be pretty interesting. All right, so we're going to talk about what fingerprints are, how the pattern is determined. We're also going to talk about the materials in a fingerprint, not because we're trying to identify a smudge as a fingerprint, but because we want to know the materials in a fingerprint so we can develop the fingerprint. Like I said, developing fingerprints, you have luminol, so you can see faint blood a little bit better. We talked about some ways of developing shoe prints, but fingerprints really stands out in that oftentimes they're invisible, and the collection methods or the development methods are very important when it comes to fingerprint collection. Okay, so we're going to talk about fingerprints, the analysis, and then we'll go back and talk about collection. All right, fingerprints, a friction ridge skin pattern. So what we like to do when we start talking about fingerprints is, if you haven't done it in a while, because I don't know what you do every Friday night, but I always look at the friction ridge skin pattern on my fingers. But you'll notice that you have bumps on your fingers and on your toes to help us grip things. And these ridges are composed of hills and valleys, raised skin and lowered skin, and they are referred to in the fingerprint terms as ridges and furrows. When we look at a fingerprint, like an inked fingerprint, so I take my finger, I press it on an ink pad, and then press it on a white piece of paper, and it looks something like what's showing there in the screen. It's important to understand that the raised area of the fingerprint, or the ridges, are what makes contact with the ink pad, and the ridges are the black lines in the fingerprint pattern. So sometimes we're going to talk about ridge endings or bifurcation, which is when a ridge splits into two. So it's important to understand that the black areas in an inked fingerprint are the ridges. Sometimes when you're developing a fingerprint, or if you're dealing with an impression of a fingerprint, it's easy to get the ridges and the valleys flipped around when you're scanning it in the software. So you always want to make sure you keep track of what is the ridge and what is the furrow. All right, if we take a close-up look at a fingerprint, we can see, the line, and we can see there's a lot of neat things that happen in the pattern, but the pattern is composed of these lines that sometimes the lines end here, and sometimes the lines split into two, and then occasionally you'll have a dot. Occasionally you'll have a, what is this? This is an island. I'm trying to see two bifurcations facing each other. Not really a good one in this example. But everybody, even though everybody's fingerprint is different, you're all going to have this basic pattern of lines in your fingerprint. All right, so how are these fingerprints developed? And why are they different among individual? Fingerprints develop early in embryonic development, as it says there. So when you're an embryo in the womb, you human hands look almost like frogs, where you have these big pads on the tip of your fingers, and as your hands grow into those pads shrivel up. So fingerprints are formed with the shriveling of those finger pads, and it's similar to like crumpling a piece of paper. If you take 100 sheets of paper and you try to crumple it the exact same way every time you crumple the paper, there's going to be slight differences in where the little wrinkles and folds and crevices are in that paper. And it's the same way with fingerprints. As that skin shrivels up, the way they shrivel is going to be due to the different pressures in the womb. So even two identical twins in the same womb, their fingerprints are going to shrivel up differently. Okay. Well, what about clones, Dr. Linville? I was watching this show called Orphan Black, and Orphan Black is incorrect. It's not right. Okay, I don't care if they're clones. They were developed. Spoiler alert: developed in different rooms from different the birth mothers or whatever they called them for clones. Okay, they would have different fingerprints. It's frustrating. The show's pretty good, other than that scientific inaccuracy. All right, so sometimes the overall pattern is based on genetics. Like you may find identical twins, they both have a lot of loops or something, but what we're going to see are the individual characteristics, the ridge endings and bifurcations. They're going to be different for every single individual. Okay, so how do we categorize these? We have class characteristics, which are patterns. Okay, and we're going to have a couple just general pattern categories of which your patterns of your fingerprints may match another person's. Again, class characteristics. And then the individual characteristics of a fingerprint are minutia. And there's no real magic number for minutia, but if you find enough minutia in a fingerprint and you can match that to a known print, then based on the experience of the analyst, that person can say with confidence, yes, this fingerprint at the crime scene matches this person and no other. All right, so what are the patterns of fingerprints? I want you to understand just 3 basic patterns. There are actually more. I think in the book it has some like double loop patterns or I forget some of the other, like an accidental whorl or something like that. So there are some subcategories of these 3 general prints. And in fact, in your fingerprint assignment, one of the prints may be one of these unusual patterns, but I just want you to focus on these 3 general patterns and being able to classify fingerprints into one of these 3 groups. Okay, so we have arch, loop, and whorl. Let's look a little bit closer at what the differences are between these 3 fingerprints. Excuse me. They all in common at the top here have a ridge that may end or split into 2, but in general the ridge starts at the left, continues across, and ends at the right. Okay, the same for the loop here, okay, and the same for the whorl. Okay, starts at the left, ends at the right. Okay, at the bottom, like close to the knuckle, it's the same thing. You have a ridge that starts at the left and ends at the right. Starts at the left, ends at the right, starts at the left, ends in the right. It's really what happens between the ridges that are going straight across at the bottom and up and over at the top that determines the pattern. For an arch, no matter where the ridge enters, it may go up and down or split into 2 or stop, but you always have them entering from the left and exiting from the right. Okay, so they always go straight across. With a loop, you'll notice here some ridges enter, wrap around, loop around, and exit from the same direction. Okay, so that's what's indicated of a loop. Also notice that for a loop, when you have these ridges that go up and wrap around, the other feature is right here where you have the wrap around in this direction, the straight across at the bottom, and the up and over here. Notice that you're forming a triangle right here, and this triangle is called the delta. All right, so a loop has 1 delta. Okay, a whorl has a ridge pattern that spirals in and sort of loops, circles around, and never really exits. The end result there, and this pattern is not the best of it, but you actually end up having 2 deltas. One here for the circle around, straight across, and up and over, and you'll have another delta over here as well. Okay, so if you're unsure about whether it's an arch, loop, or whorl, you can also look for those deltas, and if you have 1 delta, you know it's a loop. If you have 2, it's a whorl. Okay, some loops, like this is a nice big loop, some loops will just come in and loop around a little bit and have a tiny delta there, but it's still considered a loop. Okay. Once a print is categorized into just the general pattern of those 3 categories, then the forensic scientist or the software will look for minutia, and that's the details of the ridges. Okay, when you have a ridge or when you have a line, it can really do only 2 things. Okay, the ridge can split into 2, okay, or the ridge can end. All right, that's it, or it can just continue. Okay, so what a forensic scientist looks for is marking these locations of where a ridge either splits into 2 or ends. Now, these are listed in the book as sort of two unique minutiae, but really notice an island is just when you have two bifurcations right next to each other. And a dot is just when you have two ridge endings right next to each other. It's just when you have those features that are really close to each other, they sort of stand out, so it makes it easy for forensic scientists to show a jury, oh, look at this island here in the unknown, island here in the known print, or look at this dot, as opposed to, ridge endings and bifurcations, they can all start to look the same. I think you'll probably figure out this when you do the assignment, and it can become very frustrating to start marking all of these ridges and bifurcations. Okay, now the good thing about this, the fact that all fingerprint patterns are essentially the same, just composed of ridges that end or split into two, a software can scan an image of a fingerprint and automatically mark where those ridge endings and bifurcations are. But then it's up to a human to come through and sort of double check the software, because the software is dealing with, as the case right here, a very messy prints recovered from a crime scene at time. Marking the ridge endings and bifurcations tend to be pretty easy if it's an inked print. So this is one collected from the suspect over here. But here, the software may start marking these scuff marks as ridge endings and bifurcations. So it's the analyst, the human being, that has to come in and determine which ones are legitimate. Like in here, these are probably legitimate because the area of the print's pretty clear. All right, and just focus on unmarking the ones that aren't true minutia. All right. Now we can see how the minutia are marked, and for your assignment, when you're marking minutia in prints, this is sort of what you're going to do. We don't get that advanced in this course when it comes to marking minutia. So really, whether it's a ridge ending or bifurcation, like you'll notice here, the bifurcations are in blue, the ridge endings are in red. I don't care if you differentiate the two of them. I just want you to sort of put a circle around a feature is. Okay, and also notice that sometimes it's very difficult to determine what's a ridge ending bifurcation. For example, let's say I had a ridge like this and I had another ridge like this. Well, is this a bifurcation with just a little gap in it because of, a defect in the print? Or is this just a ridge ending that's really close to another ridge? Well, let's look at how both of these would be marked. A bifurcation, you put a circle around and draw a little line, splitting the two ridges in two. Okay, for a ridge ending, you draw a circle around it, and you draw a line that goes back along the ridge. Okay? So you'll notice that both of those, whether a person's calling it a ridge ending or bifurcation, they're all in general marking that something is here in this location in the print, and it's going in this direction. Okay, they both have the same general direction. So that's why you notice these little circles, and the line is telling you either the direction the ridge ending is coming from or the direction that the bifurcation is split. Okay, and then that way, if one analyst calls it a ridge ending, another analyst calls it a bifurcation, the software still sort of sees those two things as the same thing. And this is a close-up here, which depending on how big your monitor is, you can sort of see how that's a ridge ending, that's a ridge ending, and then down here a bifurcation, because we have one thing that is going into two. Of course, with the ridge endings, it's the opposite. Here we have three, one of them's ending, and after that mark, we only have two. All right. Okay, and this is something that we use in class, but we're not going to use here. All right, okay, so that's in general how fingerprints are analyzed and classified. We're going to get more into the detail of comparison a little bit later on, and also development. All right, your book has a good chapter on the history of fingerprints, and this is almost like the history of biometrics is maybe a better way of thinking about it. Now we're getting into face scans and retina scans and some other things. But early on, when it came to using fingerprints to identify a person, I want you to think of this not so much as identifying evidence at a crime scene, who did this fingerprint come from, but I want you to think of it as identifying an unknown person who is brought into a law enforcement agency, okay, brought down to the police station. Okay, so you bring me into the police station, and they're like, "Hey, aren't you the world famous thief, the professor?" Which, if I was ever a world famous thief, I think I would go by the professor. And I'm like, the professor whose actual name is Jason Linville? And I'm like, no, I'm not Jason Linville. I'm Ned Linville. I'm not very good at making up names. And so there's an interest in being able to identify a person who's not just giving a fake name, especially if they're a serial offender of some certain crime. So what they could do is they could take my fingerprints and compare them to the fingerprints of Jason Linville, the professor, world famous thief, that they have on file, and they would see that they would match, and they would go, no, you're actually this serial offender, and we're going to give you a much harsher punishment. Okay, but there are actually other methods before fingerprints to identify a person on biological measurements, and the first one was known as anthropometry, and this was taking body measurements of an individual. And with the theory, and this goes back to our very first lecture in the class, are body measurements unique to an individual? In other words, are you going to find another person who has the same length head, length arm, length from your, elbow to your shoulder or knee to your hip, et cetera, et cetera? And for anthropometry, Bertillon, who is one person, he came up with this system of 11 measurements, and there are much more than the 11 that Bertillon used shown in this diagram here. But he came up with 11 measurements for law enforcement agencies to record for offenders that they brought in. And then if they brought a person back and they were trying to identify them, they could take these measurements, compare them to their file, and have the potential for identifying somebody. Like, wait a minute, you're a world famous thief, Jason Linville, the professor, but you just grew a mustache, because I assume if I had a mustache, law enforcement agencies would have difficulty identifying me. Okay. More likely, the law enforcement agency would say, "What's that on your face?" All right, so so that was an early system. But then Henry realized, who is a different person. Henry Bertillon is not a person. Bertillon is the last name of one person. Henry or Henri is the last name of another person. He decided to do the same thing using a biological feature to identify an individual, but he settled on fingerprints because many people realize that, hey, fingerprints look like they're unique to an individual. But agencies needed a way to classify the fingerprints. So Henry sort of came up with a way to take all 10 fingerprints from a person and classify those prints in a way that before computers would allow them to be searched. So in other words, I come in, they don't know who I am, or they find a dead body in the river and they don't know it is. They can take 10 fingerprints from an unknown person or body, compare them to their database, okay, or all the fingerprint cards in their database through a systematic method where they could quickly rule out some cards who it couldn't be based on the patterns, and then identify an individual. This was still very time consuming because if you determine that they had, a loop whorl loop on their right hand, there may be several people in the system with a loop whorl loop. Okay. So what I want you to, we do a little bit extended exercise in class, and I'm not going to do this quite as long here in the online lecture. But what you can do is, number one, I have no idea how that person is holding their hands. Like, they have to be, there's either something wrong with their arms, or they're crossing their arms, or it's a reversed image or something like that. But the point is that if you look at your thumbs like a normal person, like let's pretend like the thumb is right here and the four fingers are right here, okay, then you could sort of classify the print from each of these fingers as either a loop, whorl, or arch. Now, if you know what hand the fingerprint came from, you can further classify a loop as either an ulnar loop or a radial loop. For example, if the print was from this individual and the print was a loop that started here and came out in this way, then the direction of the loop would be facing the ulnar bone. Okay? Because in your bone, go ahead and feel the two bones in your arm, or most of us have seen a skeleton. Hey, it's Halloween. Take a look at the what I'm sure are very accurate representations of skeletons on somebody's door. And there's two bones in the arms. Okay, this one close to the pinky finger right here is called the ulna. And this bone that's under your thumb is called the radius. Okay, rad. How you remember that is by giving a thumbs up and saying radical. Okay, I don't know. Somebody mentioned that. I don't know if that's the proper way to remember those. But anyhow, so if you had a print that you knew was from this left hand, then since it's going in this direction, you could say, oh, okay, that's an ulnar loop. Okay. If the print is in the opposite direction, then that would be a radial loop. Okay. But if it turns out that these prints were made from the right hand, then all of a sudden that switches, and what was an ulnar loop becomes a radial loop, and what was a radial loop becomes an ulnar loop. So you can take an unknown print, and this was part of the problem with the assignment this week. Okay, I asked you to classify things as ulnar or radial loop, but I don't tell you what hand it came from. So for an unknown print, you can't really classify the print as ulnar loop or radial loop. But on a 10 print card, where you have somebody at the law enforcement agency and you're inking their hand and you're putting their fingerprints, all 10 fingerprints on a card, you know which one came from the right hand and the left hand. So you can further break down the loops into ulnar loops or radial loop. So on a 10 print card, you have 10 prints. You have 10 letters here, an A, U, R, or W, and you can just arrange these in alphabetical order would be the easiest way to do it, and sort of go through, and if you have an unknown person, then you just sort of look, and they are A, U, U, W, U, then you go through and look for all the 10 print cards that start with A, U, U, W, U. All right. Now, the actual Henry system was a little bit more complicated than that, where he classified things as a key, where if the key matched, then you went to the major, then the primary, then the secondary, then the subsecondary, and then the final. And you can read here that the key, the ridge count of the first loop pattern, excluding the little fingers. Oh man, so if you have a loop on your ring finger, then you would use that. Then you would count the ridge count, so you'd count the number of ridges from the center here all the way out to the delta of where it came and went over. It's a little bit confusing as far as how, now if you're a trained analyst, most trained analysts would come up with the same numbers for all of these. They kept in mind there was some wiggle room. You know, some people may count 10 ridges, another person may count 11 because they may have a ridge where you're not sure whether to count it or not. But you know, the point of the Henry system is not the fact that it can get a little bit complicated or that two people might not get the exact same answer. It was just a systematic way of taking 10 prints and classifying them so that before computers, law enforcement agencies could more easily identify an individual. Okay, nowadays, we don't worry about the key and the major and all that stuff. We just have a computer scan them in. We have a computer mark all the minutia, determine what the pattern is, and then a human analyst goes through, looks at each print, and double checks. You know, they want to make sure that, yeah, these minutia are marked correctly, and also that the pattern is called correctly. They agree with what the pattern is called. Okay, and also you can scan in a 10 print card from an unknown person, and the computer can do that comparison a lot quicker than a human going through a card catalog could as well. All right, so this modern fingerprint system speeds up the process for that, and as we're going to see in a couple slides here, also allows for a single fingerprint found at a crime scene to be identified. Because with that Henry system of 10 print card identification, if you find a single fingerprint at a crime scene, you can't just compare it to the database. You can't go through and look at, oh, well, I know it's an arch, so I'm going to go through and compare it to every single arch in the database. It's not possible to do it that way. So it wasn't until modern computer systems came up where comparing it to a 10 print card was or a database was possible. I mean, if you had a suspect, you could always compare it to your suspect, right? But as far as taking a print from a crime scene that you had no idea where it came from, now we can scan it through the fingerprint system. Back then, you couldn't do that. All right. And the fingerprint systems in the United States are linked together, and it's called the, not terribly original, but Automated Fingerprint Identification System, or AFIS. Okay, so on CSI, if they're running DNA through AFIS, that is not technically. DNA goes through CODIS, and fingerprints go through AFIS. And bullets go through IBIS, probably. Okay, so that is, we went through how do you identify people, with a 10-print card based on fingerprints. And don't forget about the early anthropometry system and also the features of fingerprints. Now we're going to talk about the different types of fingerprints and how to collect them. All right, the easiest one is visible. If you see a fingerprint at a crime scene, you take a photograph of it. Okay, and I know you're thinking, oh, if it's on paper, I just put the paper in an envelope and take it back to the lab. Yeah, you could do that, but the fingerprint may rub against the envelope. It may get smudged. It may, I don't know, get wet if you're carrying it through the rain or something. The important thing about fingerprints is that if you have a good image of the fingerprint, that's just as good as the fingerprint itself. Because it's not like DNA where you have a blood stain and you need to extract the DNA from it and then physically amplify the DNA. With the fingerprint, you're scanning an image of that print, that pattern, into the AFIS system. So if you take a photograph of the crime scene, then you can just scan that photo into the system. Okay? If you take the fingerprint back to the lab, eventually you're going to take a photograph of that fingerprint or scan that fingerprint, and that's what goes into the system. So it's always an image that goes into the system, so therefore you want to take extra care to making sure you get as good of an image as early as possible. Okay, you don't need to process it. What does that mean? You don't need to treat it with chemicals or anything like that. You just photograph it and you're done for a visible print. An impression print, and in this class we've already talked about tools a little bit, and we talked about using silicone rubber to make a cast of a tool print pattern. And you can do the same thing with a fingerprint. If you do have a fingerprint in putty or in butter or something weird like that, you'd take a photograph of the fingerprint first, but like we talked about with shoe prints and making a cast of a three-dimensional shoe impression, sometimes a photograph does not capture all the details for a three-dimensional impression. So with fingerprints, you do usually want to make a cast of it. Your book says it may not need processing, but you do need to process it as far as making a cast. What do you do with the cast? Well, you normally take a cast of it. It looks just like the finger that made the print, and then you ink the cast and make a fingerprint with that cast. All right, this is where it gets exciting. Latent fingerprints. So these are the invisible fingerprints that are found on the Declaration of Independence. Okay, so you want to process those fingerprints and then find out that they spell a clue that eventually leads you to the Smithsonian in the basement of the Alamo. I don't know. I've never seen any movie starring Nicolas Cage, so I don't even know what I'm talking about. But if you try to develop fingerprints, invisible fingerprints, it depends on the material that the fingerprint is on. If it's on a piece of paper, you're going to treat it a little bit differently than if it's on a piece of glass. All right. So we're going to talk about the different ways of developing these invisible fingerprints. Boom. Okay, that's actually a fake picture. That's an inked print. So, but you get the general idea. Okay, invisible fingerprint becomes visible. When we're choosing our method, we need to think about the materials that are in a fingerprint, because essentially we want to take one of these invisible components in a fingerprint, be it an inorganic ion, a protein, amino acid, an oil, and we want to make it visible. So because there are so many different materials, listed there that are in fingerprints, that is going to lead to a lot of different chemical and physical development methods to make those invisible materials visible. Okay, so for each of the methods we're going to talk about, and I believe there's 4, I want you to know what material of those listed there, ions, proteins, amino acids, oils, what material that development method reacts with, okay? And I also want you to be able to tell me what surface is that development method appropriate for? Is it appropriate for paper, which is a porous surface, or something like a glass, which is a non-porous surface? Number one, dusting. Method number one. Dusting, oh, look at that. I even put it in bold font for you. In dusting, the dust adheres to the oils in the print. Okay, so when you make a fingerprint, okay, where the ridges make contact with the surface, you're going to leave behind oils. So it's sort of like, just like making an ink print, except what's left behind is invisible oils. Okay, the oils dry out relatively quickly and they leave behind a sticky residue on the surface of the material you left the fingerprint on. So when you draw a fine powder across that sticky surface, the powder is going to stick to where the ridges were and not stick to where the furrows made contact. So you're going to wind up with the darkness of the dust is indicative of the ridges and the light areas are the furrows. Okay, this is good for non-porous items like glass or a smooth table or a whiteboard or a cell phone, glass on a cell phone, because if we're looking at the side of the surface, the fingerprint material, sort of that sticky residue, sits on the surface. So when dust comes and makes contact with it, it's very easy for it to stick to that oil residue that's on the surface there. Okay. If you have a fingerprint in paper, okay, the oils actually absorb into the paper, all right, and the end result is dusting does not work very well on paper documents, especially if they're older paper documents. The oil has soaked in to the paper and the powder's not going to stick. Also, the paper is porous and bumpy and has a bunch of fibers. The powder is also going to stick everywhere to the paper as well. So it's not necessarily going to stick better to the ridges than it does to the other areas of paper. So dusting, not good for paper, but very good for a non-porous item like a glass jar. Okay. Now we have four. Okay, so I take it back. I guess there's 5 development methods. 1 physical, and then these are 4 chemical development methods. Okay, so again, for each of these, what material does it develop and what surface is it good for? Okay, iodine fuming iodine behaves very similar to dry ice. Most people are familiar with dry ice. It's, frozen carbon dioxide. It goes straight from solid to gas. It sort of looks like it's steaming. It doesn't really melt into a liquid form. Okay, iodine crystals are the same way. If you heat up these purple-brown crystals, they don't melt. They just sort of fume. Okay, and it's not smoke because they're not burning. They just sort of fume, and you can see this purple-brown mist coming off of the crystals. Well, if you capture those fumes inside a closed container like a jar or something, or a fingerprint development chamber, then any material you put in there, the iodine fumes, okay, the iodine molecules that are in gas stage are going to get trapped in the oils or the lipid components, which are the same thing of the oils of the fingerprint. Okay, so what does this mean? It means it's very similar to a dusted fingerprint where it works good on non-porous materials where that sticky oily residue is on the surface. But since it's not powder that's sticking to it, iodine actually also works pretty well on paper too. Okay, because even if the oils are absorbed into the paper, they're going to be there and they're going to be able to trap those iodine molecules that are in the fumes into where the ridges made contact with the paper, but not where the furrows did. Now, it may be a little bit of a fuzzy print. It may be difficult to see, but it's still possible. The other good thing about iodine fuming is that it's good for valuable items because after you stop the fuming, like if you were to fume the Declaration of Independence, okay, and you find James Madison's fingerprint. Okay, is that what happened in the movie? I don't know. Then what you can do is when you take it out, the fumes will then since they're volatile, the iodine will then essentially evaporate away from the paper that the fingerprint was on, and the fingerprint will disappear. Okay, so not that people are fuming important historical documents or anything, but you can imagine cases of art or something. There may be some cases where you don't want to throw a bunch of fingerprint powder or dip it in anhydrine, which we're going to see next for paper documents. All right, or I guess we'll see anhydrine in a little bit. Silver nitrate is another chemical method. It's not used as much. I mean, there's still a physical developer method, so I'm not going to say that it's never used, but it's just not used as much as anhydrine and some of the other materials. The silver so silver nitrate is dissolved in a solution. All right, so it looks just like a liquid, and the silver in that solution is going to react with the chloride ions in a fingerprint. Okay, so if you have a fingerprint on paper, then the oils along with the chloride ions have absorbed into the paper, and they're present in the areas where the ridges made contact with the paper. So if you dip that paper in a silver solution, the chloride ions precipitate with the silver, turn a purplish color, and you all of a sudden get purple lines where the fingerprint was, where the ridges were. Okay, so this is good for porous material. It's a little bit more sensitive than iodine fuming, but the problem is you really destroy the document when you dip it in silver nitrate. Okay, anhydrine is another development method that's very similar to silver nitride, where anhydrine, is in a solution. All right, so you have your anhydrine solution, and the anhydrine is not going to react with the chloride ions, but it's going to react with the amino acids. So because it's reacting with the amino acids as opposed to the chloride ions, I think anhydrine in some cases can be a little bit more sensitive than the silver chloride. Silver nitrate. But the process is the same. You take a porous material, a piece of paper, you dip it in an anhydrine solution, and wherever the amino acids are along the ridges, they are going to bind to the anhydrine and form purple lines. So you can actually see here in this image, it's a little bit better where you can see the purple lines from the anhydrine development. All right. And when we do this in class, we dip it. You can heat a little bit to speed the process, but you don't necessarily have to. Okay, method number 4, superglue fuming. Superglue fuming was found kind of accidentally, where the story goes that they were using a new adhesive on a piece of tape, and they sealed up these boxes, and when they opened the boxes, they found a bunch of developed fingerprints everywhere. Well, it's because the superglue that they were using as the adhesive on the tape had begun fuming, going into a gas form as it just traveled in what would be normal heat, and it began polymerizing with materials in the fingerprint. Now, the materials in the fingerprint that the superglue is reacting with are somewhat unknown, but the process is why superglue fuming works is similar to why superglue works so well as an adhesive. And also, when I say superglue fuming, this isn't like a code word or something like it's, oh, it looks like superglue. No, it is superglue. It's cyanoacrylate, which is, if you look at regular superglue, like not some fancy liquid bonding 6500 Gorilla or glue or whatever. But if it's called superglue, then you usually look at the ingredients and it says active ingredient cyanoacrylate. Okay, this is the chemical that will go, if you heat it up a little bit, from solid into a gas form as a single molecule, and one of those molecules will adhere to the fingerprint, and then another molecule will adhere to that molecule, and another one will adhere to that, and they just sort of stick onto each other until they cling together to where you can actually start to see the ridge of the fingerprint. It forms a white print, but it doesn't really stand out. Like when we do superglue fuming in I think we do it in 350 and not in 250. We like superglue fume cans. You put it in the superglue chamber for a little bit, which we just use a fish tank, and you take it out, and you have to hold up the light right to see the superglue. But then after the superglue is fumed, you can go back and you can dust it. You can dip it in a fluorescent chemical. there are a lot of ways to get a good photograph after the print has been superglue fumed. And it's really good for taking a can, you have no idea if or where the fingerprints are, and just sort of fuming and searching for prints on an entire item. All right, but because superglue has to adhere and polymerize with something on the surface of a material, okay, again, for a non-porous surface, the superglue works really well. You have one superglue molecule and another superglue molecule, and it clings to that surface. If you're dealing with paper, where all the material from the fingerprint is absorbed into the paper, underneath the paper, then the superglue doesn't really have anywhere to adhere to. So it works much better with non-porous materials like cans and bottles as opposed to porous materials like paper. Okay. For all of these chemical processes, especially superglue, but to a lesser extent anhydrine, you can also further process them by dipping them in a fluorescent dye or with some other chemical. Remember, the goal of fingerprinting is always to get an image where you can differentiate the ridges from the furrows. Now, you can imagine if you develop a fingerprint and you dust it and it's a black fingerprint on a black like Coke Zero can with some writing on it in the back, the background can get very complicated and can get difficult to scan in that black print on a black background or a pattern background. If you chemically treat these fingerprints with like a fluorescent dye, what you can do is you can take it into a dark room, shut off all the lights, and all of a sudden it doesn't matter what your background is because your fingerprint starts glowing, and it's very easy to see, okay, the glowing lines are the ridges, and everything else, no matter what color the background is, it sort of disappears. So these additional processing methods can be used to increase the contrast of your fingerprint. All right, do you develop at the scene or the lab? It really depends on the situation. I mean, you don't want to take a jigsaw and cut out all the doorknobs at a crime scene to take them back to the lab to superglue fume them. So those you probably dust maybe right there at the crime scene. If it is an item that you think the individual has touched, like a knife or a piece of paper or something, then you may submit that to the lab for fingerprint processing. If you can do it in the lab in a controlled environment, in a very expensive fuming chamber, you tend to get better results than if you try to do something at a crime scene. You know, I think with that matchbook in Beverly Hills Cop 2, Axel Foley would have been better off submitting that to the crime lab as opposed to just throwing it into a fish tank with some super glue that another officer had in their pocket, which, by the way, that would work, but the matchbook was waxy, probably waxy non-porous, and also it developed kind of quickly. All right. And it was pretty distinct and bright, but it was still, he demonstrated you could get a fingerprint from. Not to give out Eddie Murphy movie recommendations, but hey, everybody go see Norbit. Okay. I don't know, is that even the name of one of those movies? All right. But remember, whether you develop it at the scene or back at the lab, once you can see the fingerprint, or even if you can see it a little bit before you take further development steps, take a photograph of the fingerprint. You always want to photograph it throughout the entire process because you never know when you're going to go from making it look better to making it look worse. But since a photograph is all you need to scan into the system, go ahead and take as many photographs as you can. And for a skilled photographer that's trained on how to take photographs of fingerprints, you can fool around with the lighting and be able to get much better images than if you just handed me a camera and told me to go crazy. Okay. So the photograph sometimes will be the only permanent record. That's okay. Again, if you develop a fingerprint on a doorknob, okay, you don't have to submit the doorknob into evidence. You take a photograph of it, you submit that into evidence. And then you can also do a tape lift that we're going to see in the next slide there, and you can store that as well. But if you get a photo and you mess up the tape lift and completely destroy the print, you can still log that photo into evidence, use it to search the database, use it in court. Okay. A tape lift can be used for two different things. Number one, for collecting and taking the fingerprint back to the lab so you can sort of store it if you want to try to scan the tape lift into the system or take that piece of evidence into court to sort of develop that no tampering has been done with the image. The other thing a tape lift can do, it can also increase the contrast of a fingerprint. So again, let's say we have a dusted fingerprint on a soda can, on a black soda can. Well, if you use a tape lift to pick up all of the powder onto that piece of tape, then you can transfer all of that black powder onto a white card, a white background, and all of a sudden you've taken care of your complicated background problem. Okay, you get better contrast, and then you take a photograph of the tape lift or scan the tape lift into your system, and an image of that will probably get better hits out the database than if you were to try to input the photograph of that black powder print on a black background. That's it. All right, so that's it for fingerprints. For the assignment, some tips that I'm giving people is don't get too wrapped up in the patterns. Just focus on calling them either an arch, a loop, or a whorl. If you can't figure out if it's a loop or a whorl, you'll probably get credit for either one. But really the main area where students have trouble is identifying the prints. Okay, remember, not some of the prints, maybe all of the prints came from the same person. Okay, so keep that in mind. Also, all of them may have come from different people, but each print came from one of the four suspects. So don't think I'm trying to trick you and go, this print came from none of them. Okay, no, it's one of the four. So you know, it's where they make an incorrect identification. One of them is a little bit easier than the other two. And then when it comes to marking minutia, you know, take your time with that, sort of try to find a good editing software. If you're using a Mac, I think you can still use, like, there's some paint program on Mac you can use. For Windows computers, just the Windows Paint program works really good. So sort of take a look at the examples. Read through the directions and do your best as far as that goes. All right. I'll take any questions from the group. Actually, everybody hang loose. So what I do is I take some questions, and I'm going to leave this recording for a little bit. And then I'll stop the recording, and if anybody wants to ask me any questions that they don't want recorded, you can do that as well. Let me update my attendance real quick, and then as I call off your name, you are free to leave. All right, so Jamie Rogers, you are free to leave. Kaylin's free to leave. Sarah's free to leave. And Zaya's free to leave. Thanks, everybody, for attending. All right, and now I'm going to go ahead and stop the recording, and then I'll take random questions.